Alright, I'm doing this experiment again now that the sugar has settled, and I just want to show you because it's really kind of, it's not kind of crazy, it's really crazy, but I think it might look better now that there's not so much particulate flowing around. But you can see the laser, and I think it's pretty great because you can see the laser so well. But I'm putting the laser just straight out, and you can see that it's bending. You know, this is the laser normal. Bring it down, and then it's got that bend in it. It's quite interesting. And one thing that I noticed, which is a really interesting behavior, is this right here. So watch as I move it down, right? It's going down, down, down. And then right here, somewhere here, right here, it starts to move back out again, right? Before it goes away. So it's there. And as I move up, it gets closer, and then I keep moving up, and then it starts to go away again. And I think that that's really interesting, and I don't necessarily know why it does that. What I do know is that when I'm down low, the distortion of the light almost makes it look like there is a floating layer of sugar just in the tank, but there's not. So it really is quite interesting. But again, I want to highlight the way that the beam goes from being relatively a beam to kind of like this wide thing over here. And you can see it pretty... I'm trying my best to keep my hand steady, but you can see it, like if you look at this, like it is quite obviously getting thicker the farther across you go. And when you look at the laser light coming out the other side, what I'm ending up with, instead of a dot like this, it turns into, you know, a line. And it doesn't look as line-like because of how bright the laser is, but it looks like more of a line like you would expect if you were doing like a slit experiment, except if there is interference, quote-unquote interference over there, it's so tight that I can't tell. I would have to, you know, have it travel a much farther distance before I can make that out, I think. But it's hard to say. I think that it definitely is having... You would notice the interference pattern if I could get the light to travel far enough. But my apartment is too limited and the laser is too bright. But as you can see, it gets stretched out as you go down in the material. You can really see it with this red one. You can see how much it gets widened out. That's what it should look like. And it gets split up. And very bent. You can just see by how it's landing that it's obviously no longer a dot. And it almost looks like it's getting smeared, which is pretty interesting. Let's see if I can put these in at the same point. See which one goes farther when they're at the same height. Yeah, I mean, it's pretty obvious which one's going farther here. At least it is for me. Right now the green is reaching the end. They're at the same height, but the red is not even close, and the red's also way more stretched than the green is. Right? So if I put them in there, you can tell that they're at different spots here. At least I hope you can. I can't look at my camera and also see how well that looks. But they are quite obviously not the same, which you would expect. The green light should go farther than the red light because it's getting bent sooner because it has less energy. And it's getting stretched out less because, again, it has more energy. And so it should be less affected by the gravity density of the sugar here. But this is actually this experiment, when I saw this, I was in love at first sight. This is actually the craziest experiment I've ever seen, and it really just brings home everything that I was believing and also like what I've observed just in the world. Because again, I said this before, but Earth, like what's happening in here is this is just water and sugar, like a lot of sugar that sat in the water, and so it's really dense at the bottom. But as you go up, it gets less and less dense, and so you don't see that effect until you bring it down and it experiences more of the gravity, the higher density, right? And what's happening there with the density gradient basically is that the atmosphere is a density gradient. The higher up you go, the less dense the air is, right? The lower air pressure. And so, what we observe is not as drastic as this, that the light gets bent within, a foot of where it's being emitted, but it is bending the light at some rate because of the density of our atmosphere and the density and the gravity of Earth, right? And so this is what we observe in our everyday. We look at light and we see it over the horizon. We're like, oh, that's so far away. But, if we were over here and this is the horizon, right? Like if you imagine that you're over here and you're seeing this light, you would imagine that light is coming from out over that way, but it's not. It's coming from down here, right? And so, if you're seeing the light up here, you are actually seeing something that's over the curve. Like if you see that, if you were the light at the top of this, if you had your eyes at the top of this laser's reach, you would think that the light is, straight out. But when you follow it straight out, it is not, it's not where you think it would be. And that's kind of what I was trying to explain in my video, talking about how gravity is why the Earth looks flat, which is really, again, just so crazy. But this experiment really just drove home exactly what I was trying to explain in that. And so I just find it very fascinating, and I like to play around with this to just show what's going on. But yeah, that's all. Peace out.